we have a man swimming west at 2 miles per hour. We have a current going northwest at 1 mile per hour. So to find the direction and speed of the man relative to shore, we want to add these two vectors together. So we know that, so let's say that this is the point 0, 0. So if we needed a vector of length 2, then this point would be -2, 0, because we're heading west. It's because we know that the length of this vector has to be 2, so if we call this vector v, the length of v is going to be v1 squared plus v2 squared. Because we're going west, we know that our y direction doesn't move, so our magnitude of v has to be the square root of v1, and so we squared. So since our magnitude is 2, that means that 2 is v1. And we're going west, so that's in the negative direction. Now to find this point up here, we know that this is 45 degrees. If we drop down a perpendicular, we have a 45-45 triangle. So if this is 1, let's draw this triangle out. So we know our hypotenuse is 1. We know that these two sides are equal. So using the Pythagorean theorem, we have 1 squared equals x squared plus y squared. But x equals y, so 1 equals 2x squared. So we have 1/2 equals x squared. So we have the square root. So we have this square root of 1/2. So 1 over the square root of 2 is x, and these could be plus or minus. But let's think about this. We're going in the negative x direction and the positive y direction. So this is going to be the vector -1 over square root of 2, 1 over square root of 2. So now we need to add these vectors together. We need to add -2, 0 plus the vector -1 over square root of 2, comma 1 over square root of 2. So we get -2 minus 1 over square root of 2, comma 1 over square root of 2. And so that is going to give us the vector. So that is the direction we are headed. And we need to find the speed. So we need to find the magnitude of this vector. So we have the square root of -2 minus 1 over square root of 2 squared plus 1 over square root of 2 squared. When we plug this into our calculator, we're going to get 2.798. And that was in miles per hour. So that is the speed at which he is going, and he is headed in the direction of this vector right here.